Alright, so welcome everybody. We'll start with the review of page 381. You guys were saying that one is not as difficult. Are there any questions you specifically want to cover anyway? If not, we can just do a couple in here.
2
Number 2, yeah.
and 4.
And 4, yeah. Anything else?
Number 5 or 6, I don't know.
5 or 6? Let's do number 6, because 4 is part of the same problem. Okay, so this one only had 6 questions, so this is a bit less to do. Alright, so let's look at this problem. Number 2. So these are kind of word problems, right?
Yeah.
But they give you the formula as well. So it says Ricardo does a great deal of driving for his work. He generally estimates his driving time in hours, t, using the function t equals m over 60, right? Alright. And m is the number of miles.
Yeah.
So A, how many hours will it take Ricardo to drive 330 miles? So I guess t is in hours. So here A, right, for the problem section A, m equals 330, right? So we basically just need to solve for t. Right, we need the time. We have m, so we do t is 330 over 60. Now it says we can use a calculator, so we can just put in our calculator 330 divided by 60.
It is
Or
like 5.5 hours.
5.5? Yeah, so this one's like this. 6 goes into 30 5 times and a half, right? So we have 11 over 2, which equals 5.5 hours. Or 5 hours and 30 minutes,
Yeah.
right? Okay, the next one, B, is the same thing.
Yeah.
Right? It says, how many hours will it take him to drive 255 miles? So if m
255
equals 255, t equals 255 over 60. And again, you can use your calculator.
4.25.
You got what? 4.25? Alright. So that's 4 hours and 15 minutes, right? The quarter of an hour is 15 minutes. That's basically it. So for these ones, it's fairly simple. You have the formula already, right? You just put in what they give you. Let's try number 4. So number 4 has got some other things. We have Alicia is considering 3 job opportunities. At all 3 jobs, weekly pay is a function of the number of hours worked during the week. Alright, so here we have the three formulas, right? So let's see. I'll call them J1. P equals, was it 9.75? That's H. J2, P equals, was it 70? Plus 8.4. I'll put a 0 since we're dealing with dollars. Right? And the third job, interesting. P equals 380 times H over 38. Alright, and what is it asking? If she works 30 hours in a week, how much more will she earn at job 2 than at job 1? Okay, so we don't actually need P3. This one I guess is for number 5. So 30 hours, that means we have H, right?
Yeah.
So H equals 30. So we just try each one, right? J1, P equals 9.75. It's H, right? So times 30. Did you guys do that in the calculator? Two 292.5? 292.5. Okay. And for J2, it's this one. So it's P equals 70 plus 8.4 times 30, right? So what is 8.4 times 30? So you can use the calculator if you have. It's good practice to use the calculator. Pardon? 2,300 you have? Times 30? Yeah, I guess you could just do like, it would be 240 plus 120, which is 241.2. I think so. Let's just do 8.4 times 30. 252. So equals 70 plus 252. So that becomes 322. So which one's bigger? Well, we want to know how much more she will earn. Okay, so this is J1, this is J2, right? So how much more? How do we find how much more? What do we do to find how much more?
By subtract.
The difference, right? Because this one is more than this one. By how much we find the difference? The difference is subtract. So we need to difference equals 322 minus 292.5. You can also do that on your calculator. 322, 29.5. Is that one of our options? Yes. Huge. Any questions on this? They've given us formulas and we're just putting things into the formula. So we're using it's kind of like it's the same as the problems where they said, here's the x and y, if x equals this, y equals that, what is the solution? It's just you're doing it kind of with a word problem. Any questions on these two? I'll take a picture and then we can do 5 as well. Or, no, let's go on to 6 because we have a lot of material. Here we go. Pardon? Oh. Okay. I'll do 5. It's not too hard. It's 30 from last time. Okay. Let's do number 5. It's the same formula. Alright, so number 5 says, if Alicia works 40 hours per week, which of the following is a true statement? So, if she works 40 hours a week, we kind of have to think through each one. We have to put 40 into each one, right? So, H equals 40. For J1, P equals 9.75 times 40, right? You can do that in your calculators. Can you do that for me? 9.75 times 40? Pardon? 390? So do you guys get? Other guys? Your calculator? This is all dollars.
9.75. The same.
Yeah, 390? Okay. Let's try the second one, right? Now here, P equals 70 plus 8.40 times 40. So that equals 70 plus what's 8.4 times 40? 8 times 4 is 320 plus 16, 336, I think.
Times 40, right?
Yeah, 8.4 times 40. Yeah.
406.
406? Let me see. Oh, you did the whole thing. Yeah, that's correct. I was just asking for the first one, 336. And when you add these ones,
Yeah.
you get 406. So you just did it quick on your calculator because you can do the whole thing all at once. Okay, so J2 is bigger than J1. How about J3? P equals 380. Oops. 380 times h over 38. Now if you look at this, we have a 38 here and a 380 here. What can we do with that? Right? So these cancel and this becomes 10. So this one's basically 10 times h. Right?
Yes.
Which means this one will always be more than this one. So anyway, we do 10 times 40. What does that equal? 400. Okay, now we can look at the question. Alicia will earn the least at job 3. That's wrong. Job 1 is the least. Right? B. Job 1 will pay more than job 3. That's also wrong. Hi, welcome. So that's also wrong. C. Job 3 will pay more than job 2. Also wrong. Right? What does D say? Alicia will earn the most at job 2. Yes. So it's D. Any questions on that? For this one, something like this, we had to do the calculation of all of them so we could compare all of them. Any questions? If not, I'll do number 6. Let me just take a picture of it. Okay, a company is awarded a $95,000 job that will cost $5,400 per day in expenses. Profits can be calculated using the total amount they're going to get minus how much it will cost each day, right? So 95,000 minus 5,400 times D, where D equals days. What is the company's profit if the job takes 14 days to complete? Okay, so we have, this is number 6. Our formula is P equals 95,000, right? Minus 5,400 D. And then D equals 14. Right? So we put that into D and we get the answer, right? So P equals 95,000 minus 5,400 times 14. And you could put that into your calculator and you would get the answer, right? I'll do it one at a time, piece at a time. First we'll do 5,400 times 14. So that I get is 75. Yeah.
680,000.
Minus what?
That is 680,600.
But you have 2 5s. Just delete one of the 5s.
19,400.
Yeah, I think that's what I'm going to get.
19,400.
I'll put the American comma here. And so that equals, what did you say, 19,400?
Yeah, that's right.
All right. Any questions on that? You just do the calculation. Is that one of our options? It is. B. Okay, so these ones are fairly straightforward problems. You have the formula, they give it to you. You have what the one variable is, and you solve for the function. Any questions on this? If not, then I will go on to the next one, which I think you guys find more difficult. So we'll do page 383. Alright. So this one's with function notation, and a lot of the difficulty is range and domain, right? So they have, the first section says, find the domain and range of the following functions. So let's just start with the first one, number 1, right? It says f of x equals x minus 2, right? So for range, the first thing we do is we look for domain, and then based on the domain we can figure out the range, okay? So that's the first thing we do. So domain says basically what values can x be. And usually what it's looking for is there something divided by x? Right? If something's divided by x, then whatever is on the bottom, if x equals something that makes that 0, then that x cannot be that number. That's kind of what it's looking for x. Okay? So this one, there's no division by anything with x on the bottom. But if you look at this, there's no value that for x that will create a problem. So a lot of these cases, the answer for domain is all values. Alright? All values of x. Or as I write, that meaning all real numbers. Okay, it's a big R for real. So all real numbers. Okay, so now we have the domain is all values of x. So then the range is basically, is there any number that this will not be able to equal? And you have to look at the x then, to say is anything happening to the x? Like, is it being squared? Does it have absolute value? This sort of thing might change it, so that this cannot be very high. So this one, whatever x is, any value of x, this is just the same value minus 2, right? So it can basically be all values of y as well. So all numbers. Let's see, all numbers. Again, that's basically, so this one, the first one, all numbers. Domain and range is all numbers. It's kind of, you might think, it might not feel very satisfying, right? You didn't do a calculation. So a lot of this problem is not really about doing a calculation. It's more about thinking about how numbers work. It's thinking about mathematics. And so what they're asking you to do is think about what are the possibilities in this function. And what you're saying is this one can be anything. X can be anything, the f of x can be anything. Okay?
What if x 2 or 0?
Alright, if x is 2,
Yeah.
then this becomes 2 minus 2
0.
becomes 0. It could be 0. 0 is an okay number. We're not dividing by 0. You can have 0. And if x is 0, the function is minus 2,
Minus 2 is.
which is negative numbers are real numbers.
If you're going by that, it's like quadratic.
Pardon?
If you're going by
Quadratic, yes.
how's that?
So a quadratic equation will be basically,
I mean, just for this person.
for something like this, So say we have f of x equals x minus 1, x plus 2, something like that, right? That's a quadratic equation. So then this will equal x squared plus 2x minus x, so plus x minus 2, right? This is our quadratic equation. So you're asking what is the range of a function like that. Do we have any other questions like that? We do actually. Number 3. So here's the quadratic. So you need to ask yourself in this problem, right? If it looks like x can be anything, there's no limitations on s, it's not dividing by x. But the function, basically, we can try some things, right? So we try, what's f of 0? That equals minus 2, right? This is 2, this is minus 2. Okay, how about f of minus 1? Let's see what happens when we go negative, right? So this becomes 1 minus 1 minus 2. Okay, so that equals minus 2 again. Okay, let's try f of minus 2. Okay, so here we have x squared. This equals minus 2 squared plus minus 2 minus 2, right? So this equals 4 minus 2 minus 2, which equals 4 minus 4 equals 0. Okay. So and if you look at it, we can do another one. We can try f of minus 3, right? So what I'm testing here is as I go more negative, what happens, right? I'm testing it. So more negative means minus 3 squared plus minus 3. I think you guys can guess what's going to happen here, right? So here, minus 3 squared becomes 9, right? Minus 3 minus 2. 9 minus 3 minus 2, what is that?
It's 4.
It's 4. Alright, so you see, as we get more negative, we go up, right? Okay, so here's a question. How about, what happens if we go more positive, right? F of 1 equals 1 squared plus 1 minus 2, which equals 2 minus 2 equals 0. Okay, f of 2 equals 4 squared plus 2 minus 2. No, sorry, 2 squared. Becomes 4 plus 2 minus 2 equals 4. Okay, so you see what's happening. As we get more positive, we also go up. So it seems like we can't get any more negative than minus 2. Now, there's one question you need to think about. What if we have fractions inside? Right? So what if we have f of 1 over 2? Right? Something between 1 and 0. Or maybe f of negative 1 over 2. Let's try that. Okay? So this is now negative 1 over 2 squared minus, plus negative 1 over 2 minus 2. Oops, let me draw a line here. Okay? So this now equals, what's 1 over 2?
1 over 4.
1 over 4 minus 1 over 2 minus 2. So to save ourselves a bit of time here, this is going to equal
1 over 4.
It's 1 over 4 minus 2 over 4 minus, so let's just keep the minus 2. So 1 over 4 minus 2 over 4 equals negative 1 over 4 minus 2, which equals minus 2 and a quarter. So that actually is more negative than minus 2, right? So we could try going even smaller using a calculator, but it seems like I think what we'll see. Let's try it. Let's try minus 1 over 8. You see what I'm doing? I'm just like trying. Just
Yeah.
trying and trying. Minus 1 over 8 equals negative 1 over 8 squared plus negative 1 over 8 minus 2. Alright? What's 8 squared?
64.
64. So 1 over 64. What is, that's just minus 1 over 8
Yeah.
minus 2. So this we're going to have to 64. So 1 over 64
Yeah.
minus 8 over
over
64
minus
minus 2. So that equals
7
negative 7 over
Negative
64
minus
minus 2, which equals 2, negative 2 and 7 over 64. So this is even smaller than 1 over 8. Than 1 over 4, right? So it seems like, let's see, and if we get, okay, so these are getting smaller. Maybe we could try something close to negative 1. We're not going to get any smaller than 3, right? Than minus 3.
Yeah.
But you can see, like, we can't get any smaller than a certain value. It's not going to go lower than this. This function can never be lower than a certain number. So it's kind of like whatever our x and our y is, we kind of know our minus 2 is our limit. Let me do one more, just to see what's happening. Right? I'll do one more over here. Oops. Okay, and we'll do f of, let's see, f of 3/4, right? To see when we're getting close to 1. Minus 3/4. Okay? So that equals minus 3 over 4 squared minus 3 over 4 minus 2. Okay, well, 3 over 4 squared is going to be 9 over 16, right? Minus 3 over 4 minus 2. So this is going to become also 16, so that is 9 over 16 minus 12 times 3 times 4 is 12. No, yeah. 12 over 16 minus 2, which equals 9 minus 12 is negative 3 minus 3 over 16 minus 2. So we're still stuck here. It seems that the biggest value actually, when we did minus 1 over 2, we got 1 1/4, right?
Yeah.
And negative 16 is a little bit less than 1 1/4.
Yeah.
It looks like this is actually our lowest value. 2 and 1 1/4. So I would actually say, for this one, the domain is all values, and the range is f of x is greater than or equal to negative 2 1/4. Something like that. Let's try the one that they gave us, and we can see what we get. Okay? I'll just take a picture of this because it was a good exercise.
Yeah.
Because you were asking me what happens with the quadratic, right?
If you want to use it.
Pardon?
Razor, right there.
This one?
Razor, if you want.
Oh, there it is. You're right. You're right. It actually, I think, is kind of dirty. Oh no, maybe they fixed it. Yeah. Thank you. Oops, I shouldn't have erased this.
Yeah.
Oh well. I'll take a picture of this. Let me get on the board. So this is number 1. Let's try the others. When we get to that quadratic one, we'll try that one too. Okay. Well, let's do it now, actually, since we're on the same topic. So that's number 3. Oops. I'm losing. There we go. Okay. So number 3 is f of x
If 1 x square
x squared
Plus 4x
plus 4x plus 4.
four.
So this one's probably easier because there's no negatives in it, right? Okay, so first of all, I think it's a good idea to do the quadratic, right? So can you figure out what this is? We know there's no value here. It's good review. We can put x and x, right?
Plus 3x plus 6.
And here's 4. So it's either 2 or 4 and 1, right?
Yeah.
But 4 and 1 will not add up to 4,
Yeah.
right? So you're right, it has to be 2 and 2.
Yeah.
So 2 and 2, and it's plus.
Yeah.
Ah, that's nice. Right? Yeah, 2 times 2 is 4, and 2 plus 2 is 4. So this is the same as saying f of x equals x plus 2 squared. You see what I'm saying? These are the same.
Yeah.
This is the exact same times something times itself is the same thing squared.
Yeah.
Alright, so that's actually, this is going to help us. Now the domain, right, domain, so the one I did earlier was actually a much harder one than this one. Because the one I did earlier had a minus in it. That's why I had to do all those like experiments to see. This one's actually quite a lot easier. So the domain, is there any value for x where we'll get an undefined or some kind of problem? This is for x.
If x minus 2,
If x is minus 2, then this becomes 0.
0.
So 0 okay?
Yeah.
0 is an okay value for a function to be. It's only if it's undefined. If you're dividing by 0, if you do something that you get dividing by 0, then you're in trouble. But we don't have anything dividing by 0 here.
Yeah.
So the domain, again, is all real numbers. Okay? Now let's look at the range.
Excuse me?
Yes.
Can you explain what the domain means? Because I want to understand.
So the domain means what values of x will make the function work. Basically. So what values of x, so f of whatever, what values of that variable, it can be f of d, f of t, something. What values of that variable, what numbers are you allowed to choose from? Okay, usually, most functions, it's all numbers. X can be any number. But there's some functions, like f of x equals 1 over x, right? In this one, if x is 0, then we're dividing by 0. And that's an invalid, you can't do that. So basically it's all numbers except 0. Or if it's something like 1 over x plus 1, right? Then what number will make you divide by 0? Here. If x is minus 1,
Minus 1.
minus 1 plus 1 equals 0.
Yes.
So that means this works for all numbers except minus 1. So that's the domain. The domain is all numbers except minus 1. Sometimes a domain can be, you can figure out the domain from the way the problem has been worded, right? So if they're saying, for example, remember we had the, let's say f of d, profits equals 95,000, right? Minus 5,400 per day. Remember that problem from what we did earlier?
Yeah.
Right? So in this problem, we're talking about days.
Yes.
So days have to be positive,
Positive. Yes.
right? So mathematically, it will work for anything, right? By math. But by the problem that you've been given, the domain for this one is d is greater than 0.
Yes.
It has to be, right? Because we can't have negative days. We can't go back in time,
Okay.
right? So that's sort of the domain. So that you're kind of looking sometimes at the problem as well. You might even say that the domain has to be all integers. It has to be 1, 2, 3, 4. It can't be 1.5, this sort of thing. So that's something that you can look at. You have to kind of look at the problem to figure out what the domain is. So the domain is just saying what values can this variable be. And then the range is saying, given the domain, what are the possible outcomes of this equation? And often it's all numbers as well. It can be all numbers. But here, you would say basically if it's 0, right, then you could figure out what numbers this can't be, right? So say we do 0, that means f of d is, if this is, so f of 0, right, 95,000 minus 5,4 times 0, right? And that is basically 95,000. And because I'm subtracting, and these are going, this is getting up, right? So the next one, I'm not allowed to go negative. So we can try f of 1, right, equals 95,000 minus 5,400, which equals 90,600. So that means what if we're seeing is as this number goes up, this one goes down, right? So the biggest value is 95,000, right? Because it's getting more and more negative. And d cannot be a negative number, so it can't flip it and make it more positive. So the range is f of d is less than 95,000. Right? If it was maybe equal, maybe we can have a day of 0 equal. Then this is less than or equal to 95,000. Right? Because this number here will not be bigger than 95,000 because d cannot be a negative number. So the only way to make this bigger than 95,000 is if d is negative. But because d is always positive, we know it will always be less than 95,000.
Because of the minus.
Yeah, because of the minus.
Yeah,
So that's how domain and range works. Right? First you just find what is d possible, and then you write what the possible outcomes, if that's the case.
Yeah.
Okay? So that's what we're doing here. So here, we said the domain is all the real numbers, but we have a square here, right? So if x, whatever x is, right? Let's say x equals minus 2, right? X equals minus 2. Let's try that. F of minus 2 equals minus 2 plus 2 squared, right?
Yeah.
Which equals 0 squared, which equals 0.
No.
Right? Say we wanted to get something negative. Let's try f of minus 4. Right? That equals minus 4 plus 2 squared equals minus 2 squared equals 4. Alright? Let's try the other way around. F of 0, start with that. That equals 0 plus 2 squared, which equals 2 squared equals 4. Right? F of 2 equals 2 plus 2 squared equals 4 squared equals 16. So you see here, it looks like the smallest we can get is 0. Right? Whatever numbers we put in here, because even if we can get this inside down to 0. Right? But any other number, it'll just square and become more positive. Right? Anything negative or positive, it's just going to become more positive once it gets squared. So the lowest we can get is f of minus 2, where it becomes 0. So that means our range is f of x is always going to be greater than or equal to 0. Right? Because no matter what we choose for x, our f of x will always be greater than or equal to 0. Alright? It's a little bit unsatisfying, these problems, because you're not like solving for something, right? It's more you're describing the possibilities. Which is why in some regards this is kind of like, it captures more of the sort of the theory of algebra. Right? Because the whole idea behind algebra is it's an unknown. Right? We're working with an unknown. So what the domain and the range is doing is saying, okay, we know that we don't know it. But we also know what it can't be. We don't know what it is, but we know what it is not. And the domain and the range is telling us what it is not, based on the function. Based on the equation, we know that the answer here, we know the answer is anything. But here, we know the answer is not anything less than 0. So you can kind of limit a little bit already, just knowing from the function, even if you don't have anything else. You can limit it. Okay? Let's do a couple more. I'll take a picture of this. Actually, let me write down here. This one, domain x not equal 0, not equal minus 1. Here, t equals days, cannot be less than 0. Take a picture of that. So let's try. Right, so you have it as a picture. I'm going to erase these ones. Keep this up for now. Let's try the second one, for example, number 2. Right? We have f of x equals 5 over x plus 3. Okay. So, our domain, is there any value of x where we run into problems? And now what we look at is we see, is there x underneath the fraction at the bottom?
3.
We have the bottom here as a problem, right?
Yeah.
X plus 3. If this equals 0, if denominator equals 0, problem. Right? If the denominator equals 0, we have a problem. Right? So, what you can do then is you just take the denominator and you say x plus 3 equals 0. Right? And solve for x. So we subtract 3 from both sides. X equals minus 3. So this is the problem. If the x is minus 3, we will have a 0 here. So that means the domain is all x except minus 3. Or you could just put x equals not minus 3. Equals with a line through it. Okay? So that means the domain is all x equals minus 3. The range, if x is very small, right, a very small negative number, then this can be quite big. Let's have a look. So let's say f of, okay, f of something very close to 3, right? Let's say f of 3.1, like this, right? F of negative 3.1. So when we get close to our negative 3, we'll see some problems. F of negative 3.1 equals 5 over negative 3.1 plus 3. Okay? What is negative 3.1 plus 3? 0.1. Okay? So this equals 5 over 0.1, which equals 50. Okay?
Yeah.
And you can imagine if I did 3.01, I'd have 500. 3.0001, I'd have bigger and bigger, right? However, if x is big, if x is like 300, right? 5 over 303 is small. So we can have big numbers and small numbers. And we can have negatives and positives. Right? If x is negative 2.9, then this will be a positive number. Sorry, this is negative. So basically, actually, this problem, the range is all numbers. All real numbers. It can be anything. And one of the ways that I kind of know this, sort of intuitively, is I look as there is x being squared, or to the power of 4 or to the power of 3, something like that, right? If x has a power, you look at what is the highest power, right? So it's like x to the 4th minus x cubed plus x squared. The highest power will always give you more, right? It'll always cancel out the others. So is the highest power, is it an even number or an odd number? Is it x to the 4, x squared? Then that means x will probably not be much more than, like it'll have a bottom limit, depending on the rest of the problem. If it's like cubed or just x by itself, then it can be all numbers. Or if it has an absolute value, because that will make negatives positive again. Alright, let's take another example. So this one I already had a picture. Let's do number 4. That's a good example of the absolute value. F of b equals negative
Negative 6.
negative 6b.
Yes.
Like this?
Extra. Yeah.
Yeah, okay. So domain there's no fraction here, right? So it probably can be all numbers. Domain is all real numbers. There's no fraction. It could be negative numbers, it can be positive numbers, we'll still get something out. Then the range, right? Now we look at this. This is an absolute value, right? So that means whatever's in here will turn positive, right? But this one has a negative in front of it. So whatever's in here, doesn't matter what it is, it'll then negative. So that means the highest you can get is 0. And everything else will be below 0, it'll be more negative. So our range is actually, before I even do it, I can tell you f of b is less than or equal to 0. Because of this thing. You can try it if you want. We can do f of 0 equals negative absolute value negative 6 times 0, which equals negative 0 equals 0. Right? Try f of 1. Negative 6 times 1, right? Which equals negative 6 inside. Now absolute value of negative 6 becomes 6.
Yeah.
Right? So that equals negative 6. Okay? Let's try f of minus 1. Okay? Negative 6 times negative 1. Negative 6 times negative 1 is what?
Negative 7.
No.
No, we multiplied them.
No. 6.
Yeah, so 6 times 1 is 6. And negative times negative is positive.
Positive.
So it's negative. Yeah, so I'm not adding, it's the bracket, so it's like a multiplier. So that becomes negative 6. Absolute value doesn't care what the sign inside is, just becomes 6, which is negative 6 again. So you see, we cannot get any higher than 0. So that's why our range is this one. Questions on that? This is challenging stuff. This is like more,
Yeah.
it's very conceptual.
It's very okay.
Yeah, but it's very much like you're thinking about it. It's like I said, conceptual. It's not just here's the problem and solve it. Do you want me to do more on this page? More of these ones?
No, 6 maybe.
6?
Yeah,
Number 6? Okay. Let's try number 6. Alright, we have all kinds of interesting things happening here. f of z equals
Square.
z squared
-9
minus 9
divided
over
by z square
squared
-6
Minus 6
minus
z.
6z plus 9.
plus
Yeah.
9.
All right. So instantly I look at this and I'm saying, I think that I have a quadratic
Yeah.
equation here. Okay? In fact, both of them are quadratic equations. So I think let's try to solve that first. Right? So this equals something on top here, right? And something on the bottom. So let's do the top first. Z squared, Z, and Z. Okay. And then 9 has to be 3 times 3, right?
Yeah.
And since we're missing something in the middle, one is probably a plus, and the other one is a minus. Right?
Yeah.
Because then we have Z squared, 3Z minus 3Z becomes 0,
Yeah.
and 3 times negative 3 is negative 9.
Yeah.
Okay. Now the bottom one, again Z, and Z here. Again we're going to have 3's, right?
Yeah.
This 9. We couldn't, it could be 9 and 1. It could be
All
9
of
and
them
1,
Positive.
right?
Plus.
So it could be 9 and 1. However, that would become either 10 or 8
Minus.
in the middle, right?
Minus.
We don't have 10 or 8. So we can have 3 plus 3 is 6.
Minus.
Okay. But it's a minus here,
Yeah.
so there must be a minus and a minus.
Minus, yes.
Right? So minus 3 times minus 3 will give us positive 9.
Yeah.
We add them together, it gives us 6.
That's, minus 6.
Okay, so here we go. Now can we do some cancellation?
Yes.
Yeah?
Yes.
We can cancel this and this.
Yeah.
Right?
Yes.
So now we have z plus 3
Over z minus
and
3.
z minus 3. Alright. Oops, this line is not so great. Alright. Is there any value that z cannot be? Or z, as the Americans would say. What? 3. Yes, because we have a variable in the denominator, right? So if it equals 3, we'll have a 0 here. So the domain, right, so we have z minus 3 equals 0, z equals 3 leads to problems. Okay? So the domain is basically z cannot equal 3. Alright. Now, for our range. Say z equals 0, right? Then we have 3 over minus 3. So let's see. Z of 0 equals 0 plus 3 over 0 minus 3. 3 over minus 3,
Minus
which
1.
equals minus 1. Okay? How about z of... Let's try z of minus 3,
Okay.
right?
Okay.
Z of minus 3. We're allowed to do that, right? Yeah. That equals minus 3 plus 3 over minus 3 minus 3, which
0.
equals 0 over minus 6 equals 0. That's okay. We can have a 0. What happens if we get more negative? Let's say z of minus 9. Let's try that, alright? So that equals minus 9 plus 3 over minus 9 minus 3, which equals
Minus 6.
minus 6
Minus 12.
minus 12.
Oh, plus 12.
Oh, plus, no, it's minus minus.
Oh, yes.
I'm
yes.
not multiplying, I'm
Minus
adding. So minus 12, which equals 1 over 2.
Yeah.
That's interesting. So as we get more negative,
We get positive.
what?
Yeah.
Yeah, we get a positive. Let's try and see what minus 4 does. Because that's one more negative than the 3, right?
Okay.
So f of minus 4 equals
Yeah.
minus 4
Minus
plus
plus
3 over minus 4 minus 3 equals minus 1 over minus 7,
7.
which equals 1 over
Over
7. Okay.
Good.
So that's smaller than this one,
Yeah.
right?
Yes.
But I'm having problems here. What happens if we do the other way around, right?
Positive.
Positives. Let's say f of 6, right? So 6 plus 3 over 6 minus 3 equals 9 over
Over
3,
3.
which equals 6. So that's getting more positive, right? Interesting. So how do we get negative numbers? Is there a way to get a negative result? What if we do minus 2?
Right.
2.
Right? F of minus 2. Let's try that. F of minus 2 equals minus 2 plus 3 over minus 2 minus 3, which
One
equals 1 over
minus
minus
five.
5. Aha, so we got a negative.
Yes.
Okay. Let's try minus 1 then. Okay? This is just kind of, I'm just seeing how this works. Get a sense of it. Minus 1
Yeah.
plus, oops, plus 3 over minus 1 minus 3, right? Equals 2 minus 4, which equals negative 1 over 2. Okay, so that's more negative than this one.
Yeah.
And we said 0 was minus 1, right? Alright. Have we done close to 3, but not yet 3? Let's try f of 2, right? F of 2 equals 2 plus 3 over 2 minus 3, right? Equals 5 over minus 1, negative 5. Alright, so here we can get big negative numbers. Maybe if we do like f of 2.9 or something like that, right? Getting close to 3. F of 2.9 equals 2.9 plus 3 over 2.9 minus 3, which equals 5.9 over 0.1. Ah, okay. That's going to get big. That'll be like 59, right? So that means as this gets closer to 3,
Yes.
then the function goes up,
Function.
right? So it actually means we can get all numbers. We just have to choose them correctly. All right? So that means that the range is actually all numbers. All real numbers. Okay? There's no limit. It's just you and often actually, you see how finally when I came close to what my domain was,
Yeah.
I started seeing where the actual shape of the function was. You guys see that?
Yes.
So that's actually how you find the range. Is if you have something interesting in the domain, you use that. I know this is kind of complex. Here, let me circle these. But I think it's good to kind of an exercise to see how these things are working.
Yes.
Any questions? You guys were following along what I was doing? Okay. This is heavy, conceptually heavy. Let's take a break. We'll come back and do the geometry when we're done. Okay? Resume here. Okay, so we'll just do one last review number 8 over here on page 383. And so this one's a long paragraph, right?
Yeah.
It's like 6 lines of reading. Alright, so Brian is on a road trip with his best friend. They like to get up early. Each day they drive 100 miles before breakfast, and then they drive an average of 60 miles per hour for each hour they're on the road until they stop for the day. They never spend more than 8 hours on the road after breakfast. If h is the number of hours they drive after breakfast, which of the following are the domain and range of the function that represents their daily driving? Alright, that's So we have breakfast, right?
Yes.
Breakfast, and they drive, was it 100? 100 miles before breakfast. Okay,
Yes.
then after breakfast, they drive 60
Destination.
60 miles.
per hour, right?
Yeah.
So 60 H for after breakfast. And they never spend more than 8 after breakfast. So that means here H has to be less than or equal to 8, right? For this one. Alright, so H is less than or equal to 8 because they never drive more than 8.
Yeah.
So this is going to help us with our domain, right? Alright, so what do they want domain. So already, actually, oh, that's another thing. So if we look here, right? A says domain is 0 is less than or equal to H, which is less than or equal to 8. Right? So this is another question. Can H be less than 0?
No.
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 Right? Because it's hours. We can't have negative time.
Yeah.
Right? We all wish we could have negative time, but we can't. Right? We can go back. So H has to be greater than or equal to 0. So this is actually our domain already. Domain, if we put these two together, we have H in the middle, right? Which is greater than or equal to 0, and less than or equal to 8. Which of these options has that? It's 8. It's A. Right? Only A. So your answer is A. You don't need to answer the rest of it because you already know from the domain. Do you see that? Because we know H has to be less than or equal to 8 and greater than or equal to 0, our domain is H in between these two, and only A has that. So it's A. If you want, we can try to see the function, right? So the function is f of H. We start with 100, right? Plus 60H, right? This is how far we're moving. Because we start with 100, and then it's however many we're doing, however many hours, right? And then the domain, you can put these things in, right? So we need to find f of 0 equals 100 plus 60 times 0, which equals 100. And on the other side, we can do f of 8, right?
Yeah.
100 plus 60
Times
times 8, which equals 100. What's 60 times 8? No?
420.
480.
480, sorry, yes.
You did 7.
Yeah.
It's okay. 480. That equals 580. Okay, so the range is basically between these two, right? Because the domain is these two. So the range is 100 less than or equal to f of H less than or equal to 580. So they're basically driving between 100 and 580 miles every day. But we didn't actually need to do this because I already figured out it was A just from the domain.
Yeah.
This is just good practice. Any questions on that? If not, then let's start the geometry. Right, so if you look in your book, just like at the other times, there's a couple of, there's like a little mini test on this section.
Yeah.
I encourage you to do these questions. Feel free to bring them up in the next classes if you have any trouble with them. We can go over them. Also, you can leave it for like extra practice for yourself as well in the future. But we're trying to get you some extra math tests to do. So go ahead if you have time. It's not compulsory. You don't need to, but it's good practice. So go over this,
Yeah.
and feel free when I ask some problem questions to say something here that you've been doing. But for now, we're going to start with the final section, which is the geometry. So. Okay, what does this word mean? Let's see. What is geo? Do you have any idea what geo means?
Everywhere. Beautiful.
You have geography, right?
Yes.
And grapho is to write. So it's basically geography is maps of something. Geology, study of like the earth and the rocks, right? Geography is the map of the earth. Meter, what is meter? This is all from Greek. We have meter, right? It means to measure. So actually the root of this is to measure the earth. Alright? And so basically the word geometry comes from the ancient Greeks, and they were using this kind of math to take measurements. Right? Plots of land, angles, sun, earth, how far around the earth, these sorts of things. So that's why they call it geometry. But for us, it's basically looking at shapes and relationships between lines and angles and shapes. So it's much more graphic. Right? So we've been doing algebra, and that's been much more like with variables, with letters, with unknowns. This is very much drawing, charting, measuring things. Right? And for the GED, the geometry that we're doing is a lot of it is basically definitions. What are different shapes? What are their names? And what are their properties? Right? And when I say property, do you know what I mean by property? It means something that describes it, something that it has. Right? So a property of being a human is that we walk on 2 feet, right? We have complex brains, we need to eat food. These are properties of being human. Properties of being a table, usually there's 4 legs or 3 legs, something like that, right? So properties of different shapes. So a lot of what we're going to be learning is basically name of a shape, property of a shape, and then a formula for getting some values about it. So a formula for its area, like how big it is, the size of things. So that's basically what we're going to be learning with our geometry. So the first one we're looking at is something called a plane figure. Okay, so a figure is just any kind of drawing, right? You can say like, this is a figure, right? Yeah. And that's a figure, right? Yeah. It's a drawing. Right? However, a plane figure is something that, do you remember when I talked about the two-dimensional, the flat? So a plane, in geometry, a plane is not an airplane. It's not flying. Right? A plane is a flat surface. So you can imagine, this is a line, right? A line is one thing here. And what you can imagine, a line is anything that links 2 points. So the point is like a dot in space. It doesn't take up any area. It's just a single coordinate, right? It's this point, but it doesn't take up any space. It's just this thing. And you imagine another point, right? At any 2 points, you can imagine a line that goes through them, right? And that line can extend forever in both ways. Now a plane says we have a third point, okay? And a plane is anything that goes through, connects these 3. It's a big flat surface, okay? So it goes in all directions, but it has no width. So you can kind of imagine a piece of paper is kind of like a plane, okay? Although paper does have a little bit of width. A geometrical plane has no width. It's just, but it goes in all directions out, flat, okay? So a plane figure is something that we draw on a flat. It's basically a way of saying 2 dimensions. You know what 2 dimensions are, right? The 3 is like everything we live in. 2 is all flat. But you can imagine planes, you can imagine many different planes. Here's one, right? Here's one, here's one. They all go like this and they can intersect each other. And actually when one plane intersects another plane, they make a line. The line is the coming together of 2 planes. Let me see if I can show you. Right? You imagine these 2. Now this one's shaped like this, it goes all the way through. And this one's shaped like that, right? So what you can imagine is all the way along everywhere where these are connecting, right? So this plane goes this way. This plane goes this way. There's a line that goes all the way along every point where those two are intersecting in all dimensions.
Yeah.
Okay? In the same way, a point is an intersection of two lines, right? A line is an intersection of two planes. Okay? And you can also imagine a three-dimensional space. Two three-dimensional spaces intersect at a plane. You kind of can see sort of how we go out. Okay, so that's what a plane is. We can describe a plane. And there's some various shapes in the plane. Let me erase that. And our little figures. So we have some shapes. The first one is a rectangle. And some of these are things you've probably learned, quite a little bit before. So a rectangle, the main feature of a rectangle is that it has straight lines, right? And these lines are what we call parallel. Okay? So these lines, a parallel line means that two lines in the same plane, right? But they never intersect. Okay? So they keep going the same distance between each other. Right? Because if ever they started going a little bit one closer to the other, at some point they would cross.
Yes.
Right? But because they're parallel, let me write that. Two lines in the same plane never intersect. Right? They never come together. Right? So that's what parallel means. And a rectangle is basically a shape made up of two parallel lines here and two parallel lines here. Okay? And they meet at an exact corner. And we call it a 90-degree angle. Okay? So first of all, before we do this, you know what? There's a whole lot of information we need to talk about first. So first we talked about parallel. Okay? They don't actually say it, but I'm going to tell it to you. I think before we do rectangle, I don't like how this is going. Before we do rectangle, we need to say a quadrilateral. Okay? The quadrilateral is basically any shape with four sides. Any four-sided.
Shape.
Yeah, I'll put figure.
Figure.
Okay?
Okay.
Any four-sided figure. The key for these is that they're all composed of straight lines. Okay? So you make them out of straight lines. An angle is when two lines intersect. When two lines intersect, we say what is the shape of the intersection? Okay? So we draw a little thing here, okay? And we put it in degrees. So we say this is like 70 degrees. Alright? That's the angle of this intersection. And a degree basically is, if you imagine a full circle, right? The full circle has 360 degrees. Alright? So this is 70. This side would be 110. This would also be 70. And this would be another 110. Okay? And they all add up. The whole circle is 360. Okay? So if we do here, right? The full circle is 360 degrees. So you may ask, why 360, right? Why not 100? Why not a nice round number like 100? And the answer actually has to do with the Babylonians. way back, right? When the Babylonians, they were some of the first to do any kind of mathematical calculations. They decided that 60 was a special number. And so what they did is they did like, 5, 10, and then they went up to 60. And then they did things in 60s. So 60 is 6 times 60, right?
Yes.
And this is the same reason why we have 60 seconds in a minute and 60 minutes in an hour, right? It's because of the Babylonians. They divided things up into 60s. So because of that, this circle is divided into 360 degrees, okay? And it's a strange number to choose 360, but that's what we say. It's kind of, for them, was the completion, right? Because 60 was a special number, 360 was like a complete. It was 6 60s.
Yeah.
Okay? So that's why 360. And we never changed it. The French, they tried to change it in the French Revolution. They tried to change time, they tried to change weeks, they tried to change all of this. They didn't make it. They managed to change it to meters. They went from like pounds and miles
Yes.
to meters and kilograms. But these things they didn't manage to change. Because people just were too used to doing time in 60s, to doing circles in 60s. So here we have 360. So basically you have an angle. An angle is measuring what is this shape. Basically this thing in between. It's a way of measuring. So we can measure length, right? So length would be how long this is, right? You just have a certain number for the length. An angle is what is the degree of the intersection in between. Okay? So a small angle, like this, will have a lower number. This will be like 20 degrees. Okay? Then we have a bigger angle. This is like 60 degrees. Okay? And there's a special kind of angle, which is this corner.
Yeah.
Right? Where it comes like this. This is a 90-degree angle. And we often write it with this little square to show you it's a special 90-degree angle. Okay? Then you can have more angles. You can see this is a big angle. It's more than 90 degrees, right? So this is like 120 degrees. You actually can imagine a straight line.
180.
180, exactly. And you could even imagine like a weird angle. No, that's too far. Like this, right? That would be something like 230 or something. Okay? So you see how, like, as we go, as it gets more and more, as it gets more and more open, the number gets bigger. Okay? And there's no real unit of measurement for an angle. Because an angle doesn't matter if it's meters or whatever you're using. We basically just do degrees. Because it's all a measurement of a proportion of the circle. How much of the circle? Basically, how much of the circle does this angle take? Right? If it takes only a small amount of the circle, it's 20 degrees. If it takes a quarter of the circle, it's 90 degrees. Right? And you can see 360 divided by 4 is 90. So there's 4 of these. 1, 2, 3, 4 in the circle.
Yes.
Right? 360 divided by 2 is 180.
180.
There's 1, 2. So these are angles. And this is a quadrilateral. It's a 4-sided shape. Any questions on these things so far? It's kind of like a crash course into geometry. Okay? I'm going to erase this and we're going to start talking about the rectangle. But I can't really tell you what a rectangle is until you know these other things. So we'll keep this. A quadrilateral is a four-sided figure. So a rectangle is a special kind of quadrilateral. It has all four angles are 90 degrees. Okay? And also, both sides are parallel. So we do that with doing these two lines like this. That means these are parallel lines.
Yeah.
Alright? And this one here is also parallel. And the other thing, not only are they parallel, they have equal length. So this is B and B, this is A and A. Okay? It's a very special quadrilateral. Four angles are 360. Parallel lines are parallel, and they're equal to each other. There's another kind of quadrilateral called a parallelogram. Okay, the parallelogram is kind of like a rectangle, but it has less of those things. So what it has is basically all the sides are parallel. But that's it, right? There's no special angle here. However, if these sides are parallel, and this is where, if we had more time to do geometry, we could show it, it also means that the opposite sides are equal. Okay? So for parallelogram, this side equals this side, and this side equals this side. So you could have a question on the test where it tells you this shape is a parallelogram, and it has 4, right? They tell you this side is 4, right? And altogether, it equals 12. The circumference equals 12. Okay? We'll lose circumference in a bit. All sides, sum of all sides equals 12. Alright? What is this side?
4 times 2.
Yeah, 4 times 2?
Minus 12.
No.
12 minus 4 times 2 over 2.
Yeah, so because we know this equals this, so we know this one's also 4, right?
Yeah.
4.
Okay, so therefore we know altogether it's 12.
Yeah.
So it's left 12 minus 8, right?
Yeah, 12 minus, yeah.
Minus 4 times 2 equals
Over 2.
12 minus 8, which equals 4. That's
Over
right?
two.
Yeah.
Or to divide by 2, right?
Divide by 2, yeah.
And 4 divided by 2 equals
Equals
2. So x equals 2. So that's the kind of question you could get, right? They tell you it's a parallelogram, and all sides, sum of all sides, equals 12, and they want to know what is this side. And you have to use your knowledge that a parallelogram has equal sides, and a little bit of calculation. Okay, that's the kind of questions you could get with this. Parallelogram. Next one, we have what's called a trapezoid. Now you may have learned of this as a trapezium. I don't know how, in South Africa we call them trapezium, but the Americans call it a trapezoid. And that one has only 2 sides parallel. That's all you have. So you don't actually know the other angles. Okay?
Yeah.
Now, I think in this one it's not talking about it necessarily, but one thing you do know with parallel lines is that if you have 2 parallel lines and a line cutting through it like this, okay? If this angle is A, this angle is 180 minus A. Alright? These 2 angles add up to 180.
Yeah.
And the same here. So this angle is the
Equals.
same as this angle.
Exactly.
and this angle is the same as this angle. Okay? Because this is a line, right?
Yeah.
You remember, so this whole thing is 180.
Yes.
So, and because this one equals this one, then this one is 180 minus A.
Minus A.
So this is 180 minus A.
Yes.
So the trapezoid, you know that's the same here. Because these two are parallel. So if this is A, this is 180 minus A. And if this is B, this is 180 minus B. You know that for the angles. That's pretty much all you can know about a trapezoid.
Yeah.
Because the lengths could be different. Because this could go all the way out here, and it'd be like a long line down to it. So you don't know for sure. And we'll talk about, I think we do the formulas for these later. Yeah, so we're going to do formulas for areas and how to calculate the area of a trapezoid, how to calculate the area of a parallelogram. We'll do that in a little bit. But for now, we're just learning what are the shapes. Okay, so that's trapezoid. Let me take another picture. Now there's two special kinds of figures. So one is a square. Okay? And a square is a special rectangle. It's basically, it's a rectangle, right? So we have this, where all sides are equal. Okay? So we have two parallel sides, but it's all sides are equal. Okay? So whatever this length is, it's all sides are equal. There's another special one which is called a rhombus. A rhombus is a special kind of parallelogram. So remember we did the parallelogram? Let me try to do that one again. Be kind of like this. I have to make it a bit longer. And the special thing with this one is that in a rhombus, I don't know if that works quite well. That's a bit better. A rhombus also has all sides equal. So a rhombus is a special parallelogram where all sides are equal. Let me put B. So what's the difference between a rhombus and a square?
The angles.
The angles. So a square is also a rhombus. Alright?
Yeah.
A square is a rhombus that has right angles. So a rhombus can be flat. I often think of it as like a diamond. Right? A rhombus could also be like that. Right? Because these two lines are parallel, these two lines are parallel, and these sides are all equal.
Yeah.
It's as if you take a square, you flatten it. So a square is a special rhombus which has 90-degree angles. And a rhombus is basically a parallelogram that has all sides equal.
Yeah.
Okay? That's basically it on shapes. There's one other thing. For a quadrilateral, okay, this is a four-sided figure. All the angles, sum of all angles equals 360 degrees. Okay? For any quadrilateral. So even this one, which has no special shape to it, altogether that equals 360. So this one's 90 plus 90 is 180. Minus 90 is 180. Together is 360. right? This one, if I were to tell you, right, here we have a parallelogram. Draw it like that. If I were to tell you this angle here is 30, right, you could find the rest of the angles, right? Because the parallelogram, you know this is 30, so this one's going to be 150, right? And then you know also, if this is 150, this must be 150, and this one must be 30. And they all together add up to 360. Okay? These are kind of tricks we use to solve them. So that's some of the questions you'll be getting, those kind of tricks. Okay, that's it for quadrilaterals. Let's move on to the next section. So a lot of this is just like memorizing and learning names and things. So the next section is triangles. So a quadrilateral, quad is the Greek for 4, right? So triangle, what does tri mean?
2, 3.
3. Tri means 3. A tricycle means 3 wheels, right? A triad is 3 things, okay? Christians believe in a trinity, right? That God has 3 persons, 3 parts. Tri. Okay, triangle. So that means basically it's a shape with 3 angles. Right? And triangles have special properties as well. First thing is all angles, sum of all angles equals 180 degrees. Okay? So that's the first thing with a triangle. The sum of all angles equals 180 degrees. And then we have special kinds of triangles. Okay? We have what's called an equilateral triangle. Equa, what is equa? Equal, right? An equilateral triangle is all sides
Same.
the same. Okay? They're all the same shape. So this is A. Alright? An equilateral triangle. Then we have what's called an isosceles triangle. How do I spell that? Isosceles triangle. An isosceles triangle is 2 sides. Oops, that's not very good. Let's try to get this right. 2 sides. 2 sides are equal. Okay? 2 sides are equal. And then finally we have what's called a scalene. And that is where no sides are equal. Okay? In fact, I'll draw, you might confuse this one, so, yeah, like that. No sides are equal. Okay? Every side is its own. A, B, C. So these are 3 types of triangles. First one, all sides equal. Second one, 2 sides are equal. Third one, no sides are equal. It's equilateral, isosceles, and scalene. You're just going to have to memorize that. Okay? There's another kind of triangle that we find very interesting, and that's what we call a right triangle. And that's a triangle in which one of the angles is 90 degrees. Okay? Now you can have some combination of these. I could have an isosceles triangle, which is also a right triangle. All I would need is to make sure these 2 are the same. Oops, it's not quite right. Not quite a right angle. You know what? Let me do it like this. 3. There. That's about right. Yeah. So this would be isosceles
And right.
right triangle. Okay. Isosceles right triangle. So the thing is, with these, you can also use them to calculate the angles, right? So, well, yeah, let me keep on going with the types of angles. So we have a right triangle if it has a right angle in it, right? Now, because they all add up to 180, right?
Yeah.
If this is 90, it means these two together also add up to 90.
Yeah. 45.
Right? So what that means is you can only have one 90-degree angle in a triangle. Right? Because you can't have two right angles. They won't come back together. They'll just be like open.
Yeah.
If you had like maybe 89 and 89, it would be like a triangle like this. Maybe like that, and it would be like going up. But it would eventually touch it. Right? Yeah, but if you had exactly 90, they'd go up straight. That's a horrible looking shape. Okay. So we have a right angle. We also have what's called an acute. That's because we have three different types of angles. Oops. Right angle is 90. Acute angle
Measure less than.
less than 90, that's right. Less than 90 degrees. And then obtuse. Is greater. Greater than 90 degrees. Okay? So we can have an acute triangle. Oops, I need an L here. An acute triangle has all the angles are acute angles. All the angles are less than 90 degrees. So basically, often what you think of as your standard triangle, right? An equilateral triangle has to be acute. In fact, an equilateral triangle has 60-degree angles
Yes.
by its necessity. Because they're all equal. All the angles are equal, and they all add up to 180. So each one must be 60. And the final one you can have is an obtuse. Okay, an obtuse triangle has one of the angles is
More than 90.
more than 90, yeah. Right? You can have an isosceles obtuse triangle as well. It just has one big angle, but the other two sides are equal. Okay? So these are our three types of triangles based on our three types of angles. And what you can do is you can figure out, they can give you some problems, and they can say this is an isosceles triangle, right? And this angle is 70 degrees. What is that angle?
70 plus 70.
Yeah, so you know this is 70,
Yes.
so that means this one must be 7.
Yes.
Okay, because these two are the same.
Yeah. It's 40.
So that's the thing with an isosceles triangle. Not only are these two sides equal, these two angles
Not this.
are equal. Okay?
Yeah.
So this is 70, this must be 70. Okay? So we know 180 minus 70 minus 70, which equals 180 minus 140, which equals 40. So this one must be 40 degrees. So that's some of the calculations you can do. Okay. I think we're going to stop there. I think a lot of you have covered this sort of material before, right? This is not the first time you're seeing it.
Yeah.
So it's a good review, but also it should be a little easier for you. we're starting here, and we'll ramp up to some of the equations and things. But I think a lot of the geometry is probably things that you've seen before, so it's just kind of a review to refresh your memory. If it's not, take the time, do the homework. But for now, I'll give you your homework for your week. And if you find that this is really easy and you finish it quickly, do the problems from the end of the algebra section. All right, as practice. And that's page 389 and 391.
It's true.
All right. Have a good week.
Thank you so much.